Hello friends, Namaste and Jai Hind. Welcome to my
Set of
show
values.
Technology and Engineering Made Simple. In today's session, we are going to study a very important mathematical operator called dot product. In previous session, we already discussed the concept and physical interpretation of vector. Vector is a set of points which has magnitude and direction. Dot product operates on two vectors and generates a scalar value. Now here we'll see two vectors x transpose and y transpose defined as row vectors. The transpose is used to mention vector as a row vector because by default a vector is always represented as a column vector. The formal definition of a dot product is C is equal to x into y, where C is a scalar quantity. The mathematical formulation of dot product is C is equal to modulus of x into modulus of y into cos theta, where the modulus is defined as square root of summation of square of all the sample values defined for both mod x and mod y. There is a one more definition, which is C is equal to summation of xn into yn, where n varies from 1 to n. Basically, it point-to-point multiplication of xn and yn over all the sample values and then accumulated. Dot product in matrix form is also defined as C is equal to x transpose into y, where x transpose represent a row. In matrix, always a row multiplied with a column, and there is a special concept behind it, which we'll see in another session of concept of matrix and its physical interpretation. Right now, you can assume row is always multiplied with a column. Now we'll see the physical interpretation of a dot product. Basically, it is a projection of a vector on another vector. Here we can consider as a projection of vector y, which is unknown vector, on a known vector x, and graphically it is shown like this. So there is an unknown vector y which is projected on known vector x with an angle, say theta, and this projection vector is represented as a c collinear with x, where c is a magnitude in the direction of x. So magnitude of projection of y on x-axis is equal to c, and which is given by c is equal to modulus of y into cos theta, where e is a error. So cx plus e will form your vector y, and this projection error e is a function of theta. This equation can be modified as c is equal to mod x into mod y into cos theta divided by mod x. So here we multiplied and divided by mod of x. Now if you see the numerator equation, it is a dot product. So in general, c is equal to x into y divided by mod x is nothing but projection of y on x, where x divided by modulus of x represents a normalized vector x. These are all mathematical formulas. But what is a physical interpretation of the scalar value c? What does it represent, or what information it offers after dot product? So basically, it is the amount of similarity between x and y. That is, how much amount of similarity is there between two vectors x and y. So one can find out the relationship of unknown vector with a known vector x. It is also called correlation coefficient. Correlation is typically an engineering terminology used, which also describe same concept, that is the amount of similarity. Now, what is the exact use of a dot product, or what is a real life application? Basically, the human brain also works on the basis of a dot product. Whenever we see a person, basically human brain takes image through the eyes, and then it projects that image on the reference image stored inside the brain, and then it calculates the similarity. So that operation done by neuron of the human brain is also a dot product because it is a projection operation. Hence, this operation also form a computational cell in various artificial intelligence network, typically called neural network. So this is one of the very important application of a dot product. Now, how one can implement in a software? So the simple equation is C is equal to summation of xn into yn, where n is varying from 1 to n, can be implemented in a say C++ code as float c is equal to 0, that is the initial value, and then a simple for loop n equal to 0 to n, and then values of xn and yn are accumulated into C with the previous value of C is equal to 0. So this is just a 2 lines of code one can implement a dot product. Now, hardware implementation, it is implemented as a MAC operation, multiply and accumulate operation, which is a typically instruction form on various embedded and DSP processor as a computation unit. There are some vector DSP processor as well, in which this vector MAC operation can perform either 8 or 16, 32 or 64 multiplication and accumulation in one clock cycle. So such a unit are called hardware accelerator, and that we'll see it in our subsequent lecture of artificial intelligence and machine learning. Now we'll see a simple hardware implementation of a dot product. So the equation used is C is equal to summation of xn into yn, where n is running from 1 to n. Now here, if you look at this equation properly, so there you'll need two buffers, one for xn and second for yn, and then you'll need one multiplier. So the multiplier will take one set of values from x and y, that is xn and yn. It will multiply and then it will accumulate. Now the multiplier can be 8-bit, 16-bit, 32-bit or 64-bit, which will depends on the designer option. After multiplying, the value is accumulated into a variable of 64-bit, which is called A. Now this value will get added into the next operation, which is performed for xn plus 1 and yn plus 1. So this will continue for the n values, and finally one will get the scalar value, which is accumulated into the register A. So this is a way hardware architecture of a MAC is implemented. Here only one multiplier is used. This is typically used in the simple DSP processor, but in vector DSP processor there are physically 32 or 16 or 8 or 64 multipliers are available, and which will do complete operation in one clock cycle. So such type of processors are expensive, but they are required in artificial intelligence computation, which needs huge computational power. Now we'll see very important concept. What is a dot product for discrete and continuous time domain signal? So we already saw the dot product for discrete time domain signal. Here, that correlationship we'll find using this graphical presentation. Suppose there is a signal available called x of t, which is sampled at uniform interval using train of impulses. So the sample values are represented as a x of n. Similarly, there is a function available called y of t. When it is sampled, one will get y of n, and that is a vector. So we are having two vectors, xn and yn, which are obtained from xt and yt by sampling process using train of impulses at uniform interval ts. Now one can imagine when ts tends to 0, that is a limiting case, what will happen? So xn and yn will converge to x of t and y of t. So here, this is a mathematical formulation. When x of n and y of n converges to a continuous time function, x of t and y of t respectively, the summation sign will converge to integration. So conceptually, summation and integration both are same, and they define accumulation of data. So here, the discrete time domain representation of dot product, which we already saw, C is equal to summation of xn into yn, where n is running from 1 to n. and that will become integration of x of t into y of t into dt in continuous time domain. So this is a simple representation of or transformation of discrete to continuous time domain and vice versa. One can understand the definition of dot product in both continuous and discrete time domain. The continuous time domain interpretation of dot product helps in understanding many mathematical formulation typically transformed in signal processing subject. So we'll see the first transform, which is called Fourier transform, which is commonly used in electrical engineering subjects, right from signals and system, network system, control system, digital signal processing, communication system. This is a very important mathematical tool one can see. Now there is no need to by heart this formula. Now if you compare this equation of Fourier transform with a dot product equation, one can do the one-to-one mapping. X of t is mapped to x of t, which is a unknown function, while y of t is mapped to e raised to minus j omega t. So Fourier transform equation one can understand as a dot product of x of t with e raised to minus j omega t. We already studied complex function, that is e raised to minus j omega t, which is a nothing but a sine wave. So basically it is a projection of unknown function x of t on set of sine waves where omega varies from minus infinity to plus infinity. So there is no need to remember Fourier transform formulation, and it will become very simple when we'll see another definitions of Laplace transform and Z transform. Now what is a Laplace transform? It is a projection of x of t on e raised to minus st. We'll see Laplace transform in detail in our subsequent lecture. Similarly, one can see the Z transform. So here x of n is projected on z raised to minus n. Basically z raised to minus n indicates n amount of delay. Again, the details of Z transform we'll see in another session of Z transform. But here the idea is try to understand what is a dot product. So all the three equation or all the three transform are nothing but a dot product. We'll see a neuron model as one of the application of a dot product. A neuron basically forms the smallest computation unit in human brain. And why we are studying this? Because we are going to use these operation in one of our sessions called artificial intelligence, machine learning and deep learning subject. So what is a neuron perceptron model? It is a dot product plus bias plus non-linearity. So graphically a neuron is modeled as summation of wi multiplied with xi plus bias value b, and then it is passed through a non-linear function. So dot product of w with x is a fundamental operation in a basic neural network, and then bias is added and passed through a non-linear function f. Now f of x typically used is 1 upon 1 plus e raised to minus x, which is called a signum function. So right now don't worry about this signum function, which we'll see in our subsequent session of artificial intelligence and neural network. So this is one of the application of a dot product. Another application of dot product is FR filter, IR filters, transform theory. So we'll see all these application in our subsequent lecture. So here the point is we have to understand a dot product, and it has tremendous application. So once you get a grip on dot product, understanding of other subjects becomes pretty simple. Now this is a model of a neural network which is implemented using a single neuron. So on left hand side it shows a block diagram of a single neuron, and right hand side shows a neural network implemented using a single neuron. So each circle represents a single neuron, and a network layer is formed by stacking a single neuron in a vertical direction, and the layers are formed by stacking vertical layer in a horizontal fashion. So you will see input layer, hidden layers and output layer. This is a way a neural network is formed. So from programming perspective, it is not very difficult to implement because we already implemented a single neuron in a C language, and you have to just call that function in a systematic manner to form a neural network called multi-layer perceptron model. So just you have to define how many neurons are there in each layer and how many layers are there. So by adding 2 more for loops, one can implement a complete neural network using a dot product. I hope you must have enjoyed this lecture. Thank you for watching my show and have a good day.